I concede that the distance between the center of the small ball and the 3 centimeter mark was not exactly the same as the center of the heavy ball and the 3 centimeter mark over here. So now it was true, I've double checked it. So the heavy ball started with the center of mass at this line, and then when I moved it upwards all the way over here, this red line was actually above the center of mass. So this curve should have been lower. So now I have improved it. So what has to happen is that the 3 centimeter mark had to move like 1 centimeter to the right, as well as the 1/4 velocity mark had to move 1 centimeter to the right. So now the distances between the 3 centimeter mark and the center of the small ball is 14 centimeters, and the same over here. It's also, so between here and here it's 14 centimeters, and the same with the 1/4 velocity mark, it's 10 centimeters. Over here it's also 10 centimeters, and the same with the 12 centimeter with the full velocity. It's 25.8, and over here it's also 25.8. So the height is 12 centimeters. 12. It's also 12 over here. It's also 12 over here. It's also 12 over here, and 12 over here. So now it should be perfect. So this is my GoPro camera that I use to record slow motion footage. And I'm just going to show you that yes, this camera does produce distortions at the sides of the screen. So I'm going to record what the slow motion camera is seeing. All right, I'm going to show you my hand. So now my hand is in front of the GoPro camera. All right, now I'm going to move it to the left, and you can see how my hand is being stretched. All right, so yes, there is distortion. This is not something I'm editing. This is due to the lens. All right, you can see my hand is getting longer as I go to the sides of the screen. Okay, so this is due to the GoPro camera lens. All right, so yes, it does produce distortions, but only at the sides of the screen. At the center, oops, everything seems to be normal. So the reason why the small ball sometimes appear to be larger than the big ball is because when it reflects, it sometimes doesn't really travel in a perfectly straight line. Ideally it should be like this, right? Sometimes when it reflects, it goes like this, right? Like this. So it moves towards the camera. It's moving closer to the camera. So now that's why it appears to be bigger. So let me show you a couple of examples. It's not always easy to make sure they reflect. It reflects in a perfectly straight line. And sometimes this happens. See, now this happens. It suddenly stops. So I have to do many trials. See? And also the rope gets twisted, it turns around, and then I have to like turn it around again so that it doesn't, the rope doesn't twist. She does it again. There you go. See? The line gets distorted. It's not reflecting in a perfectly straight line. So that happens all the time. It's only the first few bounces that go more or less straight. I've been placing these sticks on the half velocity and the quarter velocity mark and the full velocity, and over here also the half velocity, because I would like to record it from above to finally get rid of the endless parallax discussion, so that we can see if it reflects back towards here or towards here. So yeah. So now I'm going to record it from above with my slow motion camera. So with the camera positioned right above the half mass mark. So this stick here. And then I'm going to do the same with the camera placed just above the 1/4 mark. So now, so that you can perfectly see whether or not it bounces back towards here or here. Here or here. All right. I'm doing everything I can to give you the best possible view of the reflections. Okay, by now it should be absolutely clear that the two balls always reflect back towards the half velocity marks. All right. So now what I'm going to do is I'm going to check at what position that will have to place the ball in order for the reflection to bounce back towards the 1/4 velocity. So instead of letting it drop from here, I'm going to let it drop from here and then from here and see at what position it causes it to bounce back to the 1/4 velocity. Let me do it again, but more focused on the 1/4 velocity mark. So I'm dropping it from here. Okay. I don't know if you've seen that, but I think it was around here that I had to drop it from. I had to drop it from around this height in order for it to bounce back to the 1/4 velocity mark. Not here, but only like here. So yeah, that's what I have. Final words. I think I've done everything I could to show you what happens with the reflections when I let it drop from 4 times as high, so with twice the velocity. It should be crystal clear by now. Well, it was already crystal clear, but now I've literally, I don't know what else I can do to make it more, to show you it in a better way, to make it more clear than this. Will you concede?